Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 7, looking at lessons 12 and 13, compound inequalities. And let's just start by defining what a compound inequality is. And basically, a compound inequality is going to be an expression that's combining two inequalities. And we're going to be using either and or. So taking two inequalities, we are combining them with and or to state that a value is between two other values. And so as we look at some examples here, that will start to make some more sense. So let's just jump in. Our first one here says, write a compound inequality from the following description for possible values of a number x. So it says that a number is either between 54 and 78 exclusive, or it's between 111 and 147 inclusive. All right, so anytime you're seeing exclusive or inclusive is telling you that it can be equal to. So thinking of our symbols, inclusive is telling us we're going to be using either a less than or equal to or a greater than or equal to. Exclusive means that it can't be equal to. So in that case, it's a strict inequality. We're using less than or we're using greater than. So our first inequality here is that x is between either 54 or is between 54 and 78. This one is exclusive. So x is greater than 54 and it's less than 78. Or that x value is going to be between 111 and 147 inclusive, which means that it can equal those amounts. So this is how we would write that compound inequality. So our x value between 54 and 78 exclusive, between 111 and 147 inclusive. Our second example here asks us to solve and graph the possible solutions to this word problem. So it says 3 more than 4 times a number is at most -5, or 1 less than 3 times a number, that should be, is more than 2. All right, so first inequality said 3 more than 4 times a number. And we'll use x. So 4 times a number, 3 more than that is adding 3. So 4x plus 3, that is at most. So it is, the most it can be is -5. It can be less than -5. So less than or equal to -5. Or 1 less than 3 times a number. 3 times the number would be 3x. 1 less than that is -1, is more than 2, greater than 2. So this would be how we would write that inequality. Then it's asking us to graph it. So to graph this, or I should say before we can graph this, we need to solve these inequalities for x. So let's solve this first one. I'm going to subtract 3 from each side, which gives me 4x less than or equal to -8. And then I divide each side by 4, and I get that x is less than or equal to -8 divided by 4 is -2. Second inequality, I would add 1 to each side, and I get that 3x is greater than 3. And then divide each side by 3, and I get x is greater than 3 divided by 3 is 1. So those are my two inequalities, simplified. To graph this, and I'm going to graph it up here since I've kind of run out of room, we're just going to use a number line. We're just dealing with one variable x. We don't have x and y here, so it's just on a number line. So here's 0, here's 1, here's 2. We got -1, -2, -3, and so on. All right, so x is less than or equal to -2. It can equal -2, so we use a solid circle there to show that it can equal that. And then we would be shading to the left. For x is greater than 1, cannot be equal to, so we use an open circle, and we shade to the right. So anything that's in those shaded areas would be a solution to this compound inequality. All right, and then our last one down here asks us to solve this compound inequality by graphing. And so again, we're going to simplify first. This is an and inequality. I'm going to start by subtracting the 2 from each side of this one, which gives me -x less than or equal to 5, 7 minus 2. And then I'm dividing each side by -1 to get rid of that negative. Dividing by a negative is going to change the direction of my symbol. 5 divided by -1 is -5. So x is greater than or equal to -5. With this one, I start by subtracting the 8 from each side, which leaves me with -2x greater than 2 minus 8 is -6. And then dividing by -2 on each side. Dividing by the negative is going to flip my symbol again. -6 divided by -2 is +3. And so this time when we go to graph, and I'm just going to draw out my graph here. That should be a 1. So at -5, we have a solid circle, our shading to the right. At +3, we have an open circle, our shading to the left. And so usually with an and, when you have an and inequality, you're going to have shading between 2 points like this because with and, it needs to, our solutions need to be true for both inequalities, or it needs to satisfy one or the other, and we need to satisfy both. So our graph would look like that. All right, and that's all I've got for you today on compound inequalities. Appreciate you taking the time to watch. If you do have questions, please let us know. Thanks. Have a great day.